All right, good morning, everyone. So my name is Eldon Christensen, and I am a program manager on the cluster development team. And in this session today, we're going to talk about clusters and networking. So people, I don't know, I get asked lots of questions about how should I be doing my networking? What are the considerations I need to be thinking about with cluster networks and CSV and live migration networks and iSCSI networks, and how do I design all this stuff and what's all the different considerations? So that's what I'm going to try to cover in this session. Almost everything you're going to see in here, so for the most part, actually this is the first time I've ever done this deck, so I'm hoping that this should all be new content for everybody in the room, and you should hopefully get some good nuggets out of this in the sense of most of this, I should say 95% of this is out there today, but it's really kind of shattered all over the world in the sense of one blog talks about what is effectively like 2 slides, and then another blog is like 1 slide, and then there's some online content that covers a little bit. And then I have some internal stuff which isn't really docked anywhere, so hopefully you'll get some good nuggets out of this. I'm hoping everybody gets something out of this. Other disclaimers. Actually, most of the stuff you see in here will apply Windows 2008 and up. So if you've got Windows 2008, Windows 2008 R2, 2012 clusters, most of this is going to apply across the board. I am going to, the stuff around cluster shared volumes is really more around 2012, and you'll see the 2012 changes sprinkled across in here. I also have a lot of focus around Hyper-V and virtualization, because I'm going to be talking about like cluster shared volumes and things like that. But if you have a lot of SQL clusters, again, of course, this applies across the board, or Exchange clusters, or file clusters, or scale-out file clusters. This all applies across the board. But you're going to notice a little hint. I'm going to talk a lot about some of the virtualization impact, because that has more impact than other things. Okay, so I'm going to start out just talking about some of the infrastructure fundamentals. How does cluster networking work? Then we're going to talk about some of the design considerations and planning. Then we're going to talk about some of the different options, a lot of the different dials and knobs that are under the hood that you can tweak. And then at the end, we're going to talk about multi-site cluster deployments, where we're actually deploying clusters across multiple sites and dissimilar subnets. And there's some considerations you have to think about when you think about clustering, when you're deploying across different subnets and failing over across different subnets. All right, let's start about infrastructure. And I got a lot of content in here. As I started putting this deck together, now I understand why I was getting asked so many questions, because there's a lot of content in here. So kind of hold. I know it's early, but like hold on to your pants, and here we go. So let's just basic overview. Let's start some of the basics, and then we'll start transitioning through. So clusters are doing constant health monitoring and detection between the other nodes in the cluster. So you got 2 servers, which are members of a cluster, and they're doing health detection of each other. So in the event of one of those servers becomes unhealthy, crashes, bug checks, those never happen, motherboard dies, that we can detect it, we can deem that node down, and we can fail over the applications that were running on that node and fail them over to another node. So clustering does these, and we actually do like a handshake. So we're actually doing a request, a heartbeat, are you there, and then a response coming back from the node. So one of the key points I just want to make here is it's not just a simple ping. Some HA solutions just do a very basic ping to see if the node is up, and we're actually doing a full handshake. It's actually secure between the nodes in the cluster. So clustering actually does full mesh health detection between all networks and all nodes. So here, if I have a 3-node cluster, node 1 actually has communication across node 2 and node 3. It builds network routes from across node 2 and node 3, and across all interfaces. So it's across the publics and the privates and all the other networks that you have. So we're actually doing full heartbeating between all the known interfaces. The default configuration with cluster networking is that we're sending these heartbeats once a second. Are you there? Yep, I'm here. Are you there? Yep, I'm here. Once a second. If a node does not respond to 5 heartbeats, we deem that node down. And we say, are you there? Another second later, are you there? Think of it like you're on your cell phone, and how long are you willing to go? Like, hello, hello, and nobody responds, right? And how long are you willing to sit there saying hello until you say, you know what? The call's dropped. I need to hang up. I need to redial. That's effectively what we're doing. So we give it 5 heartbeats. So 5 seconds we say, you're not there, and we shoot you and we take over. So basically, we'll kick the node out of cluster membership, we'll figure out what resources and what applications we're running on that node, and then we find another node to fire them up and start them on. Clustering actually does all communication over port 3343. We'll talk about some of the impact of that in a second. So clustering has a virtual adapter called NetFT. And what NetFT does is I almost like to think of it as like a NIC teaming driver for clustering. And effectively what it does is it's a virtual adapter, and this virtual adapter builds redundant, fault-tolerant routes across physical interfaces. So it's a virtual network interface which builds these fault-tolerant routes across the physical interfaces. So that's what we do. So for example, in most clusters, you're going to have a public communication network which goes out to your clients, and then usually you'll have another separate network, your internal or private communication, which is for between the nodes in the cluster. And actually what NetFT does is that it actually goes and discovers all the physical interfaces, discovers all the physical routes between the nodes in the cluster, and then this virtual adapter presents up effectively to the cluster service a single virtual adapter that looks like a single interface or a single network, and then under the covers it is handling fault detection and recovery across these interfaces. So that's how clustering actually seamlessly transitions. We can seamlessly transition things like inter-node communication across physical interfaces in the event of a network loss, because we've built these fault-tolerant routes across the different interfaces between the nodes in the cluster. So what else did I miss on here? So I'm going to talk about how it does like route prioritization here in a little bit. And again, we're resilient to different networks. And so again, it seamlessly can transition across the different nodes in the cluster. So you can actually view the NetFT adapter. So if you've ever seen this, if you do an ipconfig/all on a failover cluster, you're going to see this Microsoft failover cluster virtual adapter. That's what it is. So that's what you're looking at is our virtual adapter. It's completely self-configuring. So what we do is we auto-generate a MAC address for this virtual adapter based off of a hash of the local interface. So this is actually, so if you want to know, so one of the things in the past we didn't support on clusters was sysprepping and cloning nodes in a cluster that had the failover clustering feature installed. The reason for this was because when you install the failover clustering feature, we install the NetFT adapter. When we install the NetFT virtual adapter, we generate the MAC address based off of a hash of the local interfaces. So then if you take that OS image and you sysprep it and clone it and then pop it out across all the different nodes in your cluster, you fire them up. The problem is all those nodes have the same MAC address. That's why we didn't support it in the past. Now in Windows Server 2012, we actually do now support having sysprepping nodes, because that we've actually built in now in 2012 is the ability to detect MAC address conflicts across the nodes of the cluster and auto-gen new ones. But if you're on 2008 or down, you can't actually sysprep with the failover clustering feature installed. You don't have to do anything. It's completely self-configuring, so we will generate the IP addresses and and then build these fault-tolerant routes across the nodes in the cluster. So there's actually nothing you need to do with the NetFT adapter. You probably didn't even know it was there. At least I hope that's the case. Or maybe you did like an ipconfig/all. You saw this weird thing and you're like, "What's that?" But I just thought I'd give you some background. And I just have some screenshots. If you look at Device Manager, you can find it too. But it's a hidden device. So you got to go View, Show Hidden Devices, and then you'll see the NetFT adapter. Let's talk about the NetFT architecture. So it's an NDES 6.2 mini port adapter, and it basically, so if you look at it, there's so clustering uses 3343, both UDP and TCP. So the way it works is the cluster service is actually talking over TCP 3343 and actually talks to the NetFT virtual adapter. So that's kind of on the left side, on your left side. There we go. So on the left side, you're going to see the TCP. So you see the cluster service and the white arrows where the cluster service is talking over TCP 3343, and it goes down to the NetFT adapter. Then the NetFT adapter turns around, you see the blue lines, and actually goes and tunnels that communication over the physical interfaces. So then it's actually talking over UDP 3343, and then it goes out the physical NICs, and actually we have redundant communication over all physical interfaces that then connect over to the node. So the important thing to remember here is that NetFT is using both TCP and UDP 3343. So when you install the failover clustering feature, by default, we will plumb all of the firewall rules for you. So you install the failover clustering feature, we're going to go enable all the necessary firewall rules. But if you're using a third-party firewall product, or if you have a physical some network device firewall between the nodes in the cluster, just be cognizant, just be aware that you're going to have to go open up port 3343 for clustering to be able to communicate with the nodes. So the Network Topology Manager. So we have something called the Network Topology Manager in clustering, and it is actually the one that goes and discovers all of the network routing and communication between the nodes in the cluster. So it's actually determining the local interfaces and the cross-subnet networks, and then it is doing the fault determination when interfaces drop, and then it's actually handling rerouting network across them. I'll actually have more in a slide or two about how you can actually configure the Network Topology Manager and how its logic works. So I'll get to that in a second. So we have something called, so if you ever went in and right-clicked on a network interface, looked at its properties, if you look at my screenshot on the right-hand side there, you're going to see this Microsoft Failover Cluster Virtual Adapter Performance Filter. I think that's the word that's missing, filter. This is something new in Windows Server 2012. So in Windows Server 2012, we added a filter. And what this filter does is, if I back up, let me back up 2 slides. Okay, so if you look at this. So basically, cluster communication goes down, TCP 3343 hits the NetFT virtual adapter, then goes out UDP 3343 out across all network interfaces between the nodes in the cluster. Inbound does the same thing. So what we did in 2012 was we built a filter so that when the network communication is coming up the physical interface, so it's coming up, the NIC up the blue line, hits the top of the UDP stack, we have a filter sitting there. And what that filter does is intercepts it and says, oh, if you're cluster communication, let me route you directly off to the cluster service. We don't have to transverse the network stack twice. So we don't have to go up the network stack, up 3343, and then back up against on TCP. So we actually keep from transversing the NetFT virtual adapter on inbound communication. So that's what this filter is, if you see it. So if you see the filter, don't disable it. That's my little piece of advice, because it will boost your communication speeds. All right, let's talk about the different types of communication that clustering does. So there's 3 types of communication you need to think about when you think about clusters. First of which, there's the network health monitoring. Those are the heartbeats that we're sending between the nodes in the cluster. Remember, once a second, we're basically doing communication between the nodes in the cluster and monitoring the health detection of the different interfaces. The other type of communication to think about with clusters is intra-cluster communication, such as those are state changes to the database. So clustering has a database which we keep on all the nodes of the cluster that maintains state. Like, what resources do you have? What's the state of those resources? Are they online? Are they offline? And when you make state changes, such as you failover resource, which involves basically offline the resource, we update the database. Then you have to move the resource. So we say ownership change from node 1 to node 2. We update the database. Then you online the resource and we update the database. So those are state changes. There can be a moderate amount of them, but they're fairly lightweight. So those are the intra-cluster communication. It also depends on the type of cluster. You will have different amounts of intra-cluster communication. So on a Hyper-V cluster or a file server cluster, there's actually very little intra-cluster communication between the nodes. However, on an Exchange or a SQL availability group cluster, there's actually significantly more intra-cluster communication going on, because Exchange and a SQL availability group will actually use the cluster database as the master repository for metadata for their database replication. The last one I want to talk about is CSV. So with CSV, it is actually doing, so let's talk about cluster share. So CSV is cluster shared volumes. Cluster shared volumes is the clustered file system. It was first introduced in Windows Server 2008 R2. We actually did significant enhancements in Windows Server 2012. And in Windows Server 20, it was originally only supported with Hyper-V in 2008 R2. And then in 2012, we actually opened it up so we actually support any workloads running on cluster shared volumes. So cluster shared volumes actually, so with any clustered file system, you need to do orchestration of metadata updates. So when files are created or opened, you need to do orchestration of that, and all clustered file systems do that. What's unique about CSV is we're actually doing all the orchestration server side. So we're doing it between the nodes in the cluster. And in order to do that, we do it over networking between the nodes in the cluster, and we actually use SMB as a protocol transport between those nodes. So there's SMB communication and network communication going on between the nodes in the cluster. So clustering is doing orchestration of metadata updates, and in some communication, in some scenarios, we'll actually do failure recovery where we'll route lots of I/O between the nodes in the cluster, but I'm going to get to that. Key point here is there's 3 types of communication. So let's do some network design planning around these scenarios. And if you have questions, feel free to ask them as we go. So I don't mind questions as we go. So let's talk about these 3 different types of communication. So again, heartbeats, very lightweight, but they are sensitive to latency, right? If you start having latency between the nodes in the cluster, and these, remember, we're sending these heartbeats once a second, and if we don't get responses in 5 seconds, we're going to deem a node down, and we're going to shoot it and kick it out of the cluster. So if you start having lots of network latency, that could cause clusters to kick nodes out of membership. So the key point to remember around heartbeating, the most important network design consideration is quality of service. We need quality service. We need our heartbeats to get out and not get choked up. So that's why we need our quality of service so our heartbeats can get out so we don't have false positives and detect nodes as down when they shouldn't be. All right, let's talk about intra-cluster communication. Again, very lightweight. But very lightweight, but the most important attribute is quality of service. Remember, file servers, Hyper-V clusters, very infrequent is their intra-cluster communication. With SQL and Exchange, significantly more. But again, lightweight. The thing to remember about clustering is that it's a synchronous distributed system. So let me talk about a failover. So remember my failover where basically a resource is online, and then it goes offline. So how does it, and then we move it, and then we online? So let's talk about how that works. So basically what happens is that you offline a resource. We have to update all the nodes in the cluster because it's a synchronous system. So we do, so to all nodes, update. Then they have to acknowledge. Then we move, update, acknowledge, online, update, acknowledge. So if you have nodes which have latency with them, we require an ACK from all nodes in the cluster before we can move forward. So if you have nodes which have latency to them, it can actually slow down the entire cluster from moving forward because it requires an acknowledgement from all nodes before the clusters can move forward. So again, the key point here I want to talk about is that quality of service is the most important consideration with intra-cluster communication. All right, let's talk about CSV. CSV, cluster shared volumes. So there's 2 types of network communication to think about with cluster shared volumes. The first of which is metadata updates. So a metadata update would be something like you create a VHD sitting on a CSV volume. You start a VM. When you start a VM, it doesn't open. If you have a dynamic VHD, not a fixed VHD, but a dynamically growing VHD, every time that grows and does an extend of the file, that's a metadata update. This happens pretty infrequently. It's like every 50 megs, so it's pretty infrequent. But those are metadata. Or you shut down a VM. That's a close. You live migrate a VM. So those are all metadata updates. For the most part, on a stable running Hyper-V system, you guys are all sitting here, you're not fiddling with your Hyper-V systems at home, which means that they're all basically no metadata happening, right? They're just basically doing reads and writes to the files. So in general, there is no network communication going on with these Hyper-V VMs that are up and running. But when these metadata updates occur, we're doing communication basically between the nodes in the cluster to synchronize these metadata updates. The metadata, now when we do these operations, they're very small. It's just the metadata operation. There's no data payload. So when we open a VM, the open request will actually go and get routed over networking between the nodes in the cluster, very small, and then all the reads and write, once the file is open, all the data payload goes down to the disk, goes directly down through your fiber channel connection to your storage. So in general, on a cluster shared volumes that's up and running, quality of service is the most important attribute. In fact, if you have a lot of latency between the nodes in the cluster, it can actually start to impact your I/O performance. So that's something consideration to kind of think of that people don't usually think of, is that if you go and throw some junk 1 gigabit NIC and you try to funnel a whole bunch of stuff over it and you're running cluster shared volumes, this can actually start to impact your I/O and your storage performance. So something to keep in mind. That's one of the considerations. But again, it's all about quality of service. So that's the most important consideration to think of with cluster shared volumes. Now there's another attribute with cluster shared volumes, and that is that cluster shared volumes has some recovery modes in it. And basically what these recovery modes are is that if you walk up, cluster shared volumes does some really cool stuff in the sense that if you actually walk up and yank the fiber cable out of the back of the server, clustering will detect it, and then we will seamlessly route all I/O actually over SMB through another node in the cluster. So we can make that completely be seamless and transparent. Now when we start doing that, you're talking about all I/O is, instead of going over your fiber channel connection, is now being routed over your Ethernet connection over SMB between the nodes in the cluster, which is then executing the I/O on its behalf. So when you have these fault conditions, you can actually start to have a lot of I/O streaming between the nodes in the cluster. That is the only scenario where you need to think about bandwidth between the nodes in the cluster may actually be an important consideration when doing your deployments. Does this make sense? Nods, yes? All right, good. Nods, I see nods. So it's all about what SLAs do you want to provide and what sort of fault conditions. So for example, for most people, you could argue, how often is the fiber channel connection going to come out? Not that often. And then when it does happen, you're just going to live migrate all the VMs off, and hopefully I'm only running in this mode for a very short period of time. And if I have a little I/O degradation, it's not that big of a deal. Who really cares? That may be the general answer. Some of you may be like, no, I got like this super, super critical deployment I'm doing. I need to have very high-speed performance under all fault conditions. And you are the sort of people that might be thinking about, well, maybe I should be doing 10 gigabit Ethernet at the minimum. Maybe I want a pair of 10 gigabit Ethernet. Maybe I want to go 56. Maybe I want to go to InfiniBand. So something to think about. Can you control the traffic was a question. Answer is yes, and you're like 2 slides ahead of me. I'll get there in just a second. Great question. So I just want to recap. This was actually a picture from Build last year, the one the networking guys took. I loved it, so I kept it. This is the LA freeways. And here's this ambulance. So think about, here's my heartbeats, and they're trying to get through. And so the most important consideration to think about when you think about clusters is quality of service. That's the main thing I just want your mind getting out as you walk out of here. Quality of service is the most important networking consideration when deploying clusters. Do we support teaming is the question, and the answer is yes. So you can team NICs, you can team the public interfaces, you can team the private interfaces. We support teaming all the way around. Say it again, is there? So great question, great question. So the question was, is there any advantage to doing teaming if we're already doing with NetFT, building these fault-tolerant routes? So that's actually a great question. So let me talk about it. When NetFT builds these fault-tolerant routes, it's not actually doing load balancing across these routes. It's actually just there for fault tolerance. So if one route dies, we will switch. But it doesn't improve any of your quality of service guarantees, because it's going to say if I'm connected to this network, you may want to make that network a teamed network to give it better quality of service or better bandwidth. Great question. All right, so let's talk about the way you've been deploying clusters for the last decade. It is still valid, so you're still doing good things. So the way we've been recommending to deploy clusters for the last decade is that you should have one network, which is your public or client network, right? And that's for where clients, so I have my little picture of my little dude here, and he's connecting from the external network on top onto the public interfaces. You should also have a intra-cluster communication network, which is for cluster network flowing between the nodes in the cluster. This is a perfectly valid network design. But why do we do this? Right? Why have we made this recommendation for the last decade? Simply because it is a very simple way to doc in like a KB article or a blog, because it's very difficult to get across the message of what really matters is quality of service. And this is basically a very simple way of saying, of achieving quality of service, of saying, if I have my own dedicated network for intra-cluster communication, and I know that those heartbeats, then I know that nobody else is using it, I have my own network, nobody else is using it, it's all mine, I got quality of service. And it's just a very easy way to say that. There's actually many ways to achieve quality of service, so I'm just kind of educating you guys that you can actually achieve it in many different ways, and you go home to your network admins and they will be full of wild and crazy ideas on how they want to accomplish it. But this is still valid, but it's still just a very simple way to achieve quality of service. And when we usually say this, we usually say other recommendations we talk about. So clustering, we support IPv4 and IPv6. We support IPv4 only configurations. We support IPv6 only configurations, mixed configurations. We don't support using, so one consideration is AutoNet addressing. So you can't use IPv4 AutoNet addressing with clusters. Just one consideration to keep in mind. We do fully support IPv6 auto-configuring addresses. So if you have IPv6, I really like this. So for your private network, so I see a lot of people go through a lot of effort on their private network by default when you install Windows. Both IPv4 and IPv6 is there. Then I see people go through a lot of effort of like configuring static IPv4 addresses across their private network. But then what really happens is because you have IPv4 and IPv6, IPv6 is going to do a link local address. And then clustering will actually use IPv6 by default, and we will use these link local addresses between the nodes in the cluster. So I'm just letting you know that when you go through all this effort to configure configure IPv4 static addresses, you're kind of wasting your time because we don't use it because we're going IPv6 link local as long as both are bound. So in general, you can probably simplify your cluster configurations by just removing IPv4 on your private and just going IPv6 link local. Works great. We're going to preference IPv6. So the question was, why doesn't IPv4 work? And the answer is that if both IPv4 and 6 are there, and 6 is working, we're going to use 6. So it's not that it's not working, we're just not leveraging it. Let's see. Where did my clicker go? So that's what clustering will say. And then you go read a Hyper-V doc. And what do they say? Give me my own dedicated network. And then you're going to go read the iSCSI deployment guides. And what are they going to say? Give me, no, I need my own dedicated network. And then things start to get a little crazy. Because you're going to have the Hyper-V guys are going to say, hey, give me a dedicated network for host management. Give me a dedicated network for inbound virtual machine connectivity. Give me a dedicated network for live migration. Give me a dedicated network for cluster intercommunication and CSV, and then give me a dedicated network for iSCSI. And this gets a little crazy. People send me emails like, I don't even have this many PCI slots in my server. What are you thinking? And so, yes, my answer is this does get a little crazy. But what is all this about? Quality of service. It's simply saying, give me some mechanism for quality of service and isolation, or actually quality service, and this is just a simply and easy way to dock it, saying give me my own network card and then I know everything works. It's just a very simple way to do it. But there are many more sophisticated techniques to achieve this, and the answer is they're valid. Okay, so let's talk about do I really need to have, so with that in mind, do I really have to have different physical NICs in the cluster? I mean, different networks. Do I have to put in 2 physical NICs? And the technical answer is no. Clustering will work fine with just one. So clustering does support a converged networking model. So let me just deliver that message. Clustering does support converged networking. So if you want to do converged networking and you don't want to put in 2 NICs, we do support that model, where you're going to take multiple networks, you're going to maybe team them, and then you'll achieve your resiliency. Actually, I'm getting ahead of myself. This will be the next slide. But The one thing is you don't actually need 2 NICs. Is it still recommended? Yeah, I would kind of still say recommended. And our validate tool, so when you run our validate tool, it will throw a warning, just to give you a heads up if it only detects one network route between the nodes in the cluster. And it's just because validate doesn't know your user intent. It is simply saying, I can only detect one network route between the nodes in the cluster. That may be a single point of failure. It's kind of it's not, we haven't made it NetFT, or I should say, NIC teaming aware yet. Kind of a note to self, something we need to go do. But it won't detect if you have really redundant routes underneath with teaming. So it's not aware of that. So it'll say, hey, you only got one network interface. This could be a single point of failure. So I just want to give you a heads up. The validate will still throw a warning, but it's okay. Warnings are okay in validate. It's just a heads up to you. So let's talk about converged networking considerations. Remember, there's 2 things to think about when you think about clustering. One is resiliency. When we tell you to put 2 NICs in your servers, that's so that we can have our NetFT adapter build these fault-tolerant routes across the nodes, between these interfaces, between the nodes, for resiliency, so that if a single interface fails, we can switch over to another one. So it's about resiliency. However, you could actually be using NIC teaming to accomplish resiliency instead. That's perfectly valid, that you can have 2 physical NICs, you can team them, and you accomplish resiliency. The other thing, which I've been beating the drum about, is about quality of service. You need to achieve quality of service, but there are multiple ways to actually accomplish that. So if you have multiple network cards, you can actually use QoS policies to achieve quality of service. You could create VLANs and get quality of service that way. So you could team, you could have maybe 2 10 gig NICs, you could team them, you have a single logical interface, and you create some VLANs on top of them, and you achieve quality of service that way. So my key point here is, and I'm sure your networking guys at home will have other creative ideas on how they want to achieve quality of service. My key point is that as long as you are achieving resiliency and as long as you're achieving quality of service, you're actually good. So you don't have to have 2 NICs if you have other ways that you want to accomplish it and you want to do converged networking. All right, let's talk about CSV. I already kind of talked about this a little bit. Again, so CSV, we're actually routing communication between the nodes in the cluster. So there's those 2, I got those 2 boxes, one for the metadata updates, and the other one is for fault conditions. And if you look at here, I've lost network connectivity, SAN connectivity, and then what you see is that the virtual machine is actually routing over SMB all I/O, which will be executed through that node down to the storage. So again, you got to think about those 2 different conditions in that quality of service is really important for metadata updates. Bandwidth is important for failure conditions. Can you split the traffic? And the answer is no. You cannot split the different types of CSV communication. So let's talk about CSV networking considerations. So first of all, CSV needs SMB. We use that as a protocol transport between the nodes in the cluster. So don't go turn off SMB. So if you go read this, so back in the old days, for the old dogs in the room, there's this like NT4 2000, 2003 KB article that talks about configuring your heartbeat network between the nodes in the cluster. Anybody ever seen that article? You know what I'm talking about? There's written by a fool. And one of the things that article says is disable SMB. You don't need it between intranode communication. That was true in the past, and actually that is true with a non-CSV cluster. But for the old dogs who follow this, they have their policies and procedures. They've been doing it for years. They go to set up their first Hyper-V cluster. They deploy CSV. They do what they always do and turn off SMB, and then all of a sudden CSV doesn't work. So my first piece of guidance is don't do that. The other thing is that CSV also has dependencies in NTLM. NTLM v2 is fine. So if you've got group policies in place that enforces NTLM v2, that's fine. But CSV has dependencies in NTLM, so don't go disabling NTLM. And now in 2012, CSV also supports nodes which live in dissimilar subnets. We actually didn't support that in v1 with 2008 R2, but we now support it in 2012. So let's talk about some CSV performance tuning. So CSV it uses SMB. It is also integrated with SMB multi-channel and SMB leveraging RDMA. So if you have multiple NICs, you can actually do you can actually stream CSV traffic across multiple interfaces doing SMB multi-channel. Make sense? And we also take advantage of RDMA NIC. So if you have an RDMA-enabled NIC, your CSV traffic is going to go even faster. We have done internal testing, and we have found that if you disable NetBIOS on your intra-cluster communication, which CSV is using, we have seen some performance boosts. We also did some testing with jumbo frames. We didn't really see any performance enhancements. So people ask me about jumbo frames. Should I enable jumbo frames on my CSV network? My answer is we haven't really seen any benefit, but I'm not discouraging it either. So if you guys want to go do it, I have no problem with that. Jumbo frames with iSCSI. So the question was, should I use jumbo frames with iSCSI? The answer is yes. So the iSCSI team has done testing with jumbo frames and found jumbo frames helps with iSCSI. So the question was, how should I configure iSCSI with MPIO or with NIC teaming? So the answer is, up to Windows Server 2008 R2, it was only supported to deploy iSCSI over MPIO and use MPIO as your redundancy mechanism for iSCSI. Now that we are embracing converged networking, it is now supported in Windows Server 2012 to do the iSCSI software initiator over NIC teaming with the inbox NIC teaming. So that is now a supported scenario in 2012. So just some basics here. Reducing single points of failure. So when we talk about redundancy, so it's up to what level do you want to take it. So you may want to use different physical NICs. That seems pretty logical. But just kind of think about this. I've seen people put in 2 physical NICs and then connect them to the same switch. And then they have a problem with the switch, and both networks have problems. Maybe you want to use 2 network switches. You may want to use network teaming for resiliency of the individual network failures. You may even want to remove the driver as a problem. I've seen NIC drivers have bugs. And I've seen customers go and do crazy things like put in 4, 6 NICs into a server, all of the same make, all of the same model, all using the same driver. That driver has a bug and it impacts all networks and all network communication. Maybe you want to use different NICs with different drivers. And don't forget about upstream. Again, I talked about don't plug 2 NICs into the same switch, but then maybe that switch plugs into a single common device. So all I'm saying is think about resiliency all the way from the software layer and the driver to the physical NIC to the switch and everything in between. All right, let's talk about configuration options. Firewall, I already talked about firewall a little bit. So when you install the failover clustering feature, it will plumb all the necessary firewall exceptions you need for failover clustering to work. The most important ones are 3343, TCP, and UDP. If you have third-party firewall, if you have network routing devices in between, those are the most important ones. You're also going to see we open up a bunch of other things for clustering to work. And this is more about like, we open up our DCOM to be able to do our MS Clus API against it. So this is if you're going to be doing management. Let me state it that way. If you're going to be running Failover Cluster Manager and you're going to be managing your cluster, we need like WMI. So our management console requires WMI. So these are just different things which we require for clustering to work, which is beyond the core functionality for doing management of a cluster. So if you have a third-party firewall product and you want to know what it would take to be able to manage my cluster from outside the firewall, here you go. Just open up wf.msc for Windows Firewall.msc. Open that up and you will clearly see all of our firewall rules outlined with failover cluster leading them. So if you have a third-party product you want to enable, they're all right there. Pretty easy to figure out. Cluster threshold. Let's talk about our heart beating. Cluster heart beating is pretty aggressive. So once a second, we're sending these heartbeats. If we miss 5 heartbeats, we deem a node down, and we kick it out of cluster membership. We do that in the holy grail of achieving the highest levels of availability. That when something goes wrong with a node, we're going to detect it as fast as possible, we're going to take recovery actions as fast as possible, and we're going to get things back up and running as fast as possible and deliver the lowest downtime possible. Now, some of you, there's pros and cons to this. There are pros and cons to this approach. We are pretty aggressive. The problem is that what if you have an unreliable network, for lack of a better word? You have a poor network, and you have a network which has lots of transient network failures. Or maybe things go dark for a little bit, and then they come back and start working. In that scenario, so let's say you had a 7-second, let me just take this scenario, a 7-second network hiccup, where basically something went in the switch, something went dark, it got hung up for 7 seconds, and then things started working again. Now, let's talk about from an app perspective. From an app perspective, you're probably using TCP to connect to your application. You probably have a TCP IP-based application connecting in. TCP has reconnect logic that will make that seamless, so that if you have a 7-second network hiccup, TCP will make that seamless. And from a client perspective, they won't even notice, right? Things will stay up. Of course, performance is getting impacted, but from a client perspective, everything seems like it's staying up and running. However, clustering, if you have a 7-second network hiccup, is going to go, ho, ho, ho. That node is down. I'm going to shoot it, and I'm going to recover. That equates to downtime. You had some application that's running there. You had a virtual machine which is running there. We're going to shoot the node, and then we're going to cold boot that VM somewhere else. So what normally would have been, from a client perspective, as not an outage, clustering has just caused an outage. Does that make sense? So I've actually had some people make the comment to me saying, clustering causes me more downtime than it solves. And part of that, and my answer is that it depends on what sort of failures do you want to protect yourself from. So I have some customers that say, I have transient network hiccups all the time. I'd be like, okay, well, go fix your networking. But they say, oh, I don't know, it's a whole other team. But so that's my first answer, is go fix your networking. Because all clustering is, it is a health detection model, right? It is detecting the health of the network. It is detecting that the network is unhealthy, and it is taking recovery action. It's kind of like saying, so some customers say, oh, I'm going to remove clustering. And my answer is kind of like, well, that's like saying if you don't go to the doctor, you don't have cancer, right? It's like, no, you still have a problem. That just because you're not going to the doctor and nobody's telling you about it doesn't mean you don't have it anymore. So clustering is fully configurable. So you can tune these things however you want. So that's my message, is that if you want to configure the cluster heart beating, if it's too sensitive for you by default, you can crank it up. And I fully embrace that. So you can achieve either one. So maybe you're a customer who says, you know what, I don't have a lot of servers these days are pretty stable. It's pretty rare that I'm having machines crash or motherboards die. I have a lot of redundant hardware in the systems, from my HBAs to my power supplies to my yada, yada, yada. So it's pretty rare that I have a hardware failure that causes an entire server to fail. So I don't worry about those sort of conditions as much, but I have lots of transient network failures. But maybe you're a customer that says, no, I have a rock, so then maybe you want to crank up the thresholds if you're that customer. But maybe you're on the flip side, you're saying, I got a rock solid network, I trust in it, I believe in it, and I want to deliver the greatest service level agreement I can to my customers. I want to have sensitive, right? So tune it however you want. So that's my message, is you can achieve both. So by default, all of this heart beating is fully configurable. So by default, the same subnet delay is we're sending. There's multiple. Okay, let me say it. There's multiple knobs you can tune here. The first of which is the delay. That's how often we send the heartbeats. By default, it's once a second, and you can configure it between nodes which are on the same subnet and nodes which are on dissimilar subnets. So you can be doing tight heart beating between the nodes that are all in New York, doing loose heart beating across to the nodes that are in New Jersey, and all the ones within New Jersey are doing heart beating with each other. So these could all be 1 second heart beating, and these could be 2 second heart beating. Make sense? So we have different thresholds, whether we're crossing subnets or going same subnets. The other thing is that you can tune is the threshold. And we have different thresholds for either on the same subnet, where you probably want tighter thresholds, or crossing subnets where you can have looser thresholds. By default, they're all, again, pretty aggressive. Once a second, 5 heartbeats dropped. I've got the maximum on there. I think on the next slide I talk about which ones to tune. But again, I also want to reinforce the point of if you are having nodes drop out of cluster membership, your first troubleshooting step shouldn't be crank up the thresholds. All of a sudden now everything seems great because my nodes have stopped dropping out of membership. Problem resolved. Let's go home and party. Because you haven't actually fixed anything. You still have problems going on under the covers, right? So clustering has just told you have a problem, and you've just decided to crank up the thresholds to effectively mask them. So the answer is this is still having impact on your clients. This is still impacting your network connectivity, your performance. You're just ignoring them. So I want to kind of say it's not a troubleshooting tool. So with this model, we have tuned some of the, and one of the changes we've made in Windows Server 2012 is we've changed some of the defaults when it's a Hyper-V deployment. So when it's a Hyper-V deployment, we actually go and increase the thresholds. So by default, so let me talk about tuning these. Let me actually go back. So if you're going to go tune these, what would I do? I would leave the same subnet delay alone, if you're going to go home and tune these, at once a second. I leave that. What I would increase, if you want to increase something, are the thresholds. Same subnet threshold, cross subnet threshold. With that said, in 2012 R2, if you make a virtual machine highly available, we will detect that now in 2012 R2, and we will automatically increase some of the thresholds. So we will, by default, double the same subnet threshold from 5 to 10, and then the cross subnet threshold goes to 20. So if you're going to increase these, let me talk about that. Actually, I'm going to jump back a slide again. And the AV people are probably hating me for this. What was I going to say here? So my TCP story. Okay, so let's go back to TCP. So what is the definition of downtime? Let's talk about that. Definition of downtime is when for most people, is when the clients can no longer connect to that virtual machine. When the clients can no longer connect to that virtual machine and whatever is running inside that virtual machine, that is usually the definition of downtime, and that's when you should take recovery action. And that's usually based off of a TCP IP-based application running inside the VM, which is based upon the TCP reconnect window. So my guidance is that if you start to get the heartbeat thresholds to exceed the TCP reconnect window, it doesn't do any good, because then now it's all effectively down. So my guidance is, even though we support cranking up the threshold to 120, which could be 120 seconds, 2 minutes, I wouldn't do that. I probably wouldn't go over about 20 seconds. So I would make like 5 as the default. That's aggressive mode. We set it to 10 on a Hyper-V deployment by default now in 2012 R2. And if you want to go even looser, you could probably go about 20, but I wouldn't really recommend going over 20 because then you're starting to exceed the TCP reconnect window, and then it's down from a client perspective, and all you're doing is extending your downtime. One thing we need to talk about is the trade-off. So let's talk about the trade-off. So do you want to just go home and say, crank up everything? There is a cost to this, right? In the sense of, if it takes us, if you set, let's say the 2 minutes, let's get crazy. You set the 2 minutes. So normally we would detect the server's down in 5 seconds and we would take recovery action. Your downtime is 5 seconds plus like 6 seconds for arbitration on the drives, plus it's maybe let's say like 15 seconds. It's about 15-second recovery time, let's say that. Now, if you crank it up to 2 minutes, node crashes, you yank the power cord. Sit there for 2 minutes waiting for that thing to detect it's down, and then add another 6 seconds for arbitration and a couple more seconds for regroup. So does that make sense? So you've now gone from about a 15-second downtime to like 2 minutes and 8 seconds downtime. Does that make sense? So there's a trade-off. There's a trade-off. You say, I crank up my heartbeat thresholds, I now have resiliency to all these brownouts that my network guys can't give me a stable network, but it costs you downtime when things actually do go wrong. Yeah?
So if server 2012 R2, now that's Hyper-V default, is that not recommended setting for server 2012 and server 2008 R2?
So the question was, you guys have set these thresholds by default. Is that now kind of the recommended setting even for down level? Sure, you could go set your down level. Actually, I wrote a blog all about this too, and it's actually, I have it linked in the deck, so you'll get the deck. But sure, yeah, you go home and I would set your 2008 R2 Hyper-V clusters to this. So now let me talk about, okay, so let me say that. If you're running Hyper-V, usually the definition of downtime to a virtual machine is TCP. I would crank it up to at least 10. You could probably even go up to 20. I wouldn't go beyond 20. Let's talk about everybody else. Let's talk about scale-out file servers. On your scale-out file servers, don't go cranking up the heartbeat thresholds. Why? Because a scale-out file server provides a zero downtime guarantee, in the sense that if you walk up and yank the power cord out of the back of a node, we will detect it, and we will fail over all those SMB sessions, and it will be seamless. In order to achieve that, we have to have very aggressive health detection and recovery, because we have to land all of that before the SMB session times out. So if you crank up the heartbeat thresholds on your scale-out file server, the result is that it will take us longer to detect it's down, longer to recover, could exceed the SMB session SMB session timeouts, and as a result, it will cause downtime where it should be no downtime. Does that make sense? So Hyper-V good, crank those up. Scale-out file server bad, leave those default tight. If you're a SQL deployment, most people I talk to, SQL, the downtime associated with SQL is usually very important. Most people I talk to like to leave their SQL fairly aggressive for their, these mission-critical Tier 1 SQL deployments, and they're willing to go make the networking investments to make sure they have a reliable network. Exchange will actually crank up the defaults as well. Exchange clusters will crank up the defaults. You probably don't even notice it because clustering is kind of hidden underneath Exchange. So the question was, what about SQL always on? I would probably leave those fairly tight as well. This is there. This is just like a reference. So you can actually crank up heartbeating during create cluster if you want to, so when you create a cluster. So when you set the cluster properties, they will affect during cluster runtime, and you can actually affect it during create time as well. So a consideration. Clustering only detects one interface per logical subnet. So here's the mistake some people make, is that they say, I want clustering to use multiple networks. I'm going to put in multiple networks, and then I'm going to put them both in the same server, and I'm going to stream across them at the same time. Clustering will only detect one. So what you have to do is, if you want to have multiple network interfaces with clustering on the same subnet, use NIC teaming. That's the key message there. Binding order. So setting the binding order used to be really important a decade ago. It is getting less and less important with each release as the networking guys are getting smarter and smarter and smarter with the networking stack. It is still recommended to go and set your binding order. So if you go and set your binding order, you want to set, and think about this. So binding order is for outbound communication. It is for network connectivity going outbound. So which network should I use when I want to go connect from the server to someone else? And there's a GUI for doing it. You can go into the properties. There is no command line interface, but there's like a web download tool that you can do it. Network roles. So clustering has three different types of network roles that it will define for a network. So a cluster network maps to a logical subnet. So we will basically detect all the logical subnets connected to each node in the cluster, and then we will pair them. So you'll look here and you'll say, I have a single logical network, and you can see I have two nodes here. I have node 34 and node 35, and here are my two network interfaces. So there's basically both of these nodes have network interfaces on the same node, and you can both see they're on the 172.24.10 network, 1201, 1206. And so they're basically two network interfaces on each node in the same logical subnet, and we build those as a cluster network. You can then define how those cluster networks are to be used. So basically, there's either disabled cluster communication, which means we will not send any heartbeating, we will not send any intra-cluster communication, we will not send CSV traffic across it. You can enable it and then there's cluster communication only and enable for client communication only. The only difference between these two, let me just say that, the only difference between a 1 and a 3, these two settings, these are only for our wizards and our UIs. So basically, this defines whether we should create a a IP address resource and a network name resource for that network when we go and create. So you go through the wizard and you create a highly available scale-out file server or highly available file server. That basically says, oh, go create a IP address resource and bind it on this interface if we don't have that. And it also infects some of our prioritization, which I'm going to get to. And it will impact, it will affect the prioritization of live migration traffic. So here's how we define these. So here's how we configure these. So clustering will automatically try to configure the role for you. So basically, okay, so the new logic, so we used to never set a cluster network to disabled by default. We now will with Windows Server 2012. If we detect a network interface has the iSCSI software initiator bound to it, we will then configure it to disabled for cluster use. We'll say, oh, this is an iSCSI network. We're not going to use it. Let's disable cluster communication on it for you automatically. So that's new logic. If we detect that there is no default gateway present, we say, oh, there's no default gateway present, which means this is probably a network for intra-cluster communication. It's not a routed network. It's just for communicating between the nodes in the cluster. We're never going to go outbound to talk to external clients. This is for internal communication only. And then if we detect a default gateway, then we'll say this is for both client and external communication. And these are configurable via PowerShell. I just have a little PowerShell example there, and via the Failover Cluster Manager UI tool as well. So determining network prioritization. So we will determine, we will assign a metric value to the different network interfaces. This metric value will define which network we are routing inter-cluster communication, CSV traffic, and live migration traffic. So the lower the metric value, did I say this right? So the lower metric value has a higher priority. So you want the cheapest network. So always think about it like you're going to go to McDonald's, you're going to buy the cheapest thing you can find, right? You buy you always want to pay the lowest cost you can. So it's the same thing with the network. We want to use the lowest cost network we can. Networks are assigned metric values based off of a couple different attributes. One of which is that we start with like a value of 80,000. So we assign it based off of the role. So if it's a public network, we're going to give a higher cost. If it's an internal cluster communication network, we're going to give a lower cost. Say this is a better network, this is the one you want to use. And then once we have that, then we evaluate. Is it RDMA enabled? Is it RSS enabled? What's the speed of the network? This is all new in 2012. We will evaluate, is this a 1 gigabit NIC, a 10 gigabit NIC, and then we will let that influence the metric value to define which one is the best network to pick. So that's why you see this value is like not actually 40,000 because it's actually being influenced by link speed, RDMA, and RSS capable, and we're reducing the cost. Another thing is that if there are multiple networks which are of about equal cost, so are less than 16 metric values apart. So if I had one that was 39,984 and 39,985, clustering would say these networks are effectively equal cost. Let's use them both. So what we do is, so when I say use them both, so clustering builds this full mesh heartbeating. What we'll do is we'll build a network route to node 1 across maybe this interface, and node 2 across that interface, and node 3 across this interface, and 4 across this one. So when I say load balance, I use that loosely, because we're not actually load balancing. You can think of more like we're just distributing different connections over different interfaces because they're of equal value. So hopefully, you never have to mess with this. But if you need to, you can. So you can actually go and modify via PowerShell what the metric values are. So if you set it to auto metric equals true, that means let clustering decide for me. It will look at the network role setting. It will look at the RSS and NIC speed and RDMA and determine which ones are the best one to use. If you say, no, I need to go override that because I want to determine which networks I want which traffic to flow over, you can do that. So one consideration is with CSV. CSV uses SMB multi-channel in Windows Server 2012 now, and that will actually kind of override, has different logic than this. So let me talk about that. Actually, I'll talk about live migration, then I'll talk about that. So live migration uses the same heuristics. So what will happen is that clustering will go and build all the metric values for all your networks, and the lowest cost one will be used by clustering. We'll say, this is the lowest cost one. We're going to use this for intra-cluster communication and CSV traffic. The second lowest one will then be used for live migration. And that will be the default one used by live migration. And if these networks become unavailable, then we just move up the stack and we move up to different ones. So again, that's how we build prioritization, and then if a network interface fails, we switch between them. And if you don't like it for live migration, you can modify it as well. We actually moved the setting in the UI in Windows Server 2012. It used to be you'd right-click on a VM. Now you right-click on network, so I just want to give you a heads up that we moved it. All right, so let's talk about multi-channel, CSV multi-channel. So CSV is integrated with SMB multi-channel. What that means is that CSV will now stream traffic over multiple interfaces using them both at the same time and give you really high bandwidth aggregation across the two. Let's see, actually, let me talk about the logic on the next one. What did I miss on this slide? So the key point here is that going and tuning which network, your network prioritization, your network metric values, actually by default won't have an impact on CSV. CSV will use SMB by default and it has its own logic. So let's talk about what that logic is. So what the SMB multi-channel logic is, that first off, it will only use networks which are enabled for cluster use, and it needs to be only use networks which are set for internal cluster communication. So if you have multiple NICs which are all set for internal communication, CSV will stream across them. Then it will basically try to figure out which NICs are the best. So it'll look and see if there's RDMA-enabled NICs, if there are RSS-enabled NICs, and this one is actually teaming aware. The SMB multi-channel logic will actually go and look for team NICs. And then it will look and see if it finds multiple NICs which are of similar values, similar configurations, and then it'll do SMB streaming across the two. Now, if you don't like this logic, at the bottom, you can disable this. So if you disable SMB multi-channel, I got the command line on the bottom there, and enable SMB multi-channel false. If you disable SMB multi-channel, then CSV traffic will fall back to NetFT. And when it falls back to NetFT, it starts using the cluster metric values. So there's the magic. So there's the kind of thing. Just remember this. With CSV, it uses SMB multi-channel logic. If SMB multi-channel is not available, then it falls back to NetFT logic. And NetFT logic uses the metric values I showed you on the previous slide. Uses this logic. All right. Quaz policies. So in Windows Server 2012, there were some Quaz policies that were introduced for the first time. There's two different ones to think about. One is prioritization. Another one is there's bandwidth allocation Quaz policies. Now remember, from my beginning a while ago, the most important to think about is quality of service. Because of that, the most important Quaz policy to think about is prioritization. Because we need to have those heartbeats get through, you want to think about, so in general, I recommend setting, if you want to go set Quaz policies, set prioritization. So set the priority flow control. If you're using CSV, you may also want to go set bandwidth allocation. And if you're going to go set bandwidth allocation, I recommend setting the relative minimum bandwidth allocation. Because what CSV is in general, it's just about quality of service, but every once in a while you can have this burst traffic, right? We're in failure recovery modes. And it's the same thing with live migration. So I just have some examples here. So with live migration as well, live migration in general is not doing anything, but every once in a while it has some burst traffic. So you want to make sure that isn't starving the bandwidth on the network interfaces, that you do a converged networking model, you're running everything over a single NIC. All of a sudden, every once in a while, you get these, you do a live migration and boom, you're slamming 6 gigs of data across whatever's allocated to RAM of the VM, and you're pushing that big massive chunk across between the nodes in the cluster. You don't want these little spikes to choke things. The most important thing to be thinking about is priority flow control, because we want to prioritize those cluster heartbeats. So if you look here, I've set cluster to a priority of 6. It's the most important. I've set SMB, so maybe you would want to set SMB priority if you're doing a CSV, or you're doing SMB file-based storage, and then maybe my live migration. So the default is 0, so that means everything else. So these 3 would be more important than everything else, and clustering would be the most important. And then basically that's prioritizing TCP and UDP 3343 is what that setting does. So iSCSI planning, we talked about this kind of already. We had a good question earlier. So with iSCSI, it's recommended that, so the default recommendation has always been to use MPIO. You can now, with 2012 in a converged networking model, use network teaming. When you go configuring your network priorities, you want to set your iSCSI network interface at the bottom. You usually want to disable your iSCSI network for cluster use, because you don't want to be having CSV traffic flowing over this and then having storage IO traffic all trying to compete over that same network. So let's try to get those separated. So one of the new features in Windows Server 2012 is that we have new heartbeat logging. So what we used to have is we have the cluster log, which is this pretty verbose log for all the cluster communication. And we had a NetFT debug channel as well for just NetFT. So if you want to troubleshoot NetFT heartbeat drops, you could turn on the special logging. And it was extremely verbose. But what we found is that there was this pain of you would call in saying, I'm having a problem, and you have to go turn on the special channel to get the data you needed to troubleshoot. So now in Windows Server 2012, we will actually, when we start dropping heartbeats, we will actually we will auto-magically detect that we're dropping heartbeats and start cranking up the verbosity in the cluster log. So we don't fill it with noise all the time, but when things start failing and going wrong, we start cranking up the verbosity in the log so that you get the data you need. So here's my message with this. So we have the route history length. That's how much history we're going to crank up into the log, is usually double the heartbeat threshold. So if you listen to if you're going to go take the guidance that we talked about 10 minutes ago, where you're going to go crank up your heartbeat thresholds, I would increase this as well. So by default, this is set to 10, which is double. So heartbeats, if after 5 heartbeats, we kick nodes out, and we actually retain the last 10 heartbeat verbose logging. So if you're going to go set this to like 20, if you're going to go set heartbeat threshold to 20, I would double this to 40. Make sense? So that's my general rule. Double whatever you go set your heartbeat thresholds, your logging that will be retained. That'll help make sure when things go wrong, you have the data you need. All right, let's talk a little bit about multi-subnet clusters. So in Windows Server 2008, we added support for nodes that could reside in dissimilar subnets. SQL now supports this in SQL 2012, and Cluster Shared Volumes now supports this in Windows Server 2012. Supports clusters that reside in dissimilar subnets, so 1.10.10 and 1.20.20. You can also, this is actually, remember I talked about earlier that we have this network topology manager, so you can control this traffic. So if you have a multi-subnet or a multi-site clustering, you may want to configure these. So you can actually, by default, which is the orange on the far left, we will, as soon as we establish communication between 2 networks on the same logical subnet, we will deem that to be a network interface. If you want us to cross subnets, we can do that as well. And if you have a multi-subnet cluster, you may not have communication between all networks and all networks routes. So you can actually set that to a value of 2, which was new in 2012. The file share witness. So the file share witness is an SMB share used for storing as a witness and determining when you have a multi-site cluster, usually used in a multi-site cluster, is used for determining when nodes should drop out, which node should stay up and which node should drop out of cluster membership. So let me talk about the file share witness really quick. In general, the file share witness, it has no bandwidth requirements. So let me say that. So when designing and deploying your file share witness, it has no bandwidth requirements. So don't go set up some high-speed NIC because we don't need it. So here's the way, let me talk about the algorithm of how file share witness works. It's a timing-based algorithm. So basically the way it works is 2 nodes are up and running, and they're in communication, and everything's great. Nodes lose communication with each other. Whoa, can't talk to each other. What do? The node that owns the file share witness races out, and he grabs a lock on a file that resides in the file share witness. The node that resides over here has a delay built in, and he sits there and waits. I think it's 6 seconds. And he will sit there and wait for 6 seconds, and then he will try to go grab a lock for the file. Whoever gets the lock first wins. And whoever doesn't shuts them, so goes, oh, I didn't win the file share witness, I shut myself down. So the answer is that it doesn't really matter what, the bandwidth between the nodes is very small, and it's only used when nodes split. So don't worry about bandwidth. Quality of service is probably the most important. But the answer is it doesn't really matter what the quality of service is as long as it's fairly equal, right? As long as it could be slow, but as long as they're both slow because it's a timing-based algorithm on who, it's a race to the file share witness, whoever gets there first. And then the last consideration is it kind of doesn't matter what's the worst case scenario? Worst case scenario in your deployment. This node has a ton of latency, this node has none, and he's smoking fast. He's going to dig. The snail is crawling, trying to get to the file share witness, and the hare races and gets there first, and then he gets there last, and he loses. Basically, all that happens is this node drops out of cluster membership, and this node wins, and he stays up. So the worst case is that the cluster still stays up, you just have a different node win. So not the end of the world. You can maybe argue one is my primary site, one is my DR site, and I wanted my primary to win. So all I'm saying is don't over-design your file share witness. I see sometimes people get really worked up wanting to do a lot of considerations on the file share witness. So let's talk about multi-subnet considerations. So when you deploy a multi-subnet cluster, you deploy a single network name resource, and that network name resource has dependencies on 2 IP address resources. And what happens is so basically what you'll have IP address resource. So let's say this is a multi-subnet cluster. I got one node in 10.10, one node in 20.20. I'm going to have 2 IPs, one for 10.10 and one for 20.20. When the group fails over and comes online on this node, it's going to go, where do I have a network on here? So I have a 10.10. So the 10.10 resource comes up, the 20.20 is down. When I fail over, it's going to flip. It's going to go, oh, I have a 20.20 network, so this is going to come up and this is going to go down. So you have 2 IPs, but only the correct one's going to come online depending on which site you're on and which subnets there are. Why does this matter? Let's talk about some of the concepts. So this is cool. This is awesome. I can now deploy clusters that reside across different data centers with different subnets, and I can do disaster recovery failover across them, and that's pretty awesome. But there are some trade-offs, because in the past, you always had to stretch VLANs across sites to do a disaster recovery cluster. And your networking people probably hated you for wanting to stretch VLANs across your sites, and I just had a lot of people complain about that. So let's talk about the considerations. So here's what happens, is that you have a name which is online on your 10.111 network. It's going to go register with DNS. So whack whack foo is associated with 11.111. That DNS server is going to replicate to all the other DNS servers, and your clients are going to obtain that record from the DNS server. So what happens on a failover? That address has now changed. Foo has gone from a mapping of 10.10 to a mapping to 20.20. You now have to update that DNS record. That happens fast. Cluster fails over, comes online fast, registers with DNS. Now the considerations are, how long does it take your client to get that updated IP? So the first thing that has to happen is you have to replicate that DNS record to all the other DNS servers. And how long does that take? Default configuration for DNS servers with an AD integrated zone is 15 minutes. Maybe it'll take you longer. I don't know. Whatever your network, your DNS topology is. Then the next question is, how long does it take that client to get that DNS record? Default configuration, the DNS time to live is 20 minutes. So there's some impact. On a site failover, IPs change. It could take several minutes to update DNS records across the DNS servers, several minutes before clients go and hit the updated, go get the updated records from DNS. All right, so how do I mitigate this? So what are some mitigations around this? First off, I say scale up. Opposed to doing one node and one, so you have different SLAs for different types of failure conditions. If I have a server failure, I have local failover. So I fail over if a server motherboard crashes, machine bug checks, I fail over and it's a site-level local failover because I have multiple nodes on each site. That delivers me one service level agreement. In the event that I have a complete site outage, so that delivers me fast failover in seconds, no IPs change. Then I have a different SLA for site failover. Maybe if a data center burns to the ground, it's okay if I have 20 minutes of downtime. Maybe that's okay. But maybe you're a stock trader and you say it's not acceptable. If that's not acceptable, another mitigation is you could stretch VLANs. If you stretch VLANs on a failover, IPs don't change. DNS records don't have to be updated. No additional downtime. Another thing you can do is that some of these network companies, like Cisco, have devices which will abstract all of this. So effectively, you have a network device in the middle where you're talking to like a 30.30 address. So when I do a failover from 10.10 to 20.20, clustering will go update the routing device, but the routing device is abstracting the client, so the client never actually changes. They stay at 30.30, even though clustering is changing underneath, and we're just updating the routing device, and the routing device is handling moving the clients across between to the right IPs. Another mitigation you can do is that you can configure the network name settings. So we have different settings. So you can set register all IPs. And basically what that does is instead of switching the IPs on failover, we'll register them all in DNS. So when we do a failover, the IP actually the client is smart enough to get multiple IP records returned in a single DNS entry. And then it knows I have multiple IPs. If I'll try one, if that doesn't work, I'll try another one. Then you don't have to switch the IP. SQL has integrated into this logic, and it supports this. So you can do a SQL site failover and not actually have to, it actually has the intelligence to get back multiple IPs and then go handle switching across the different DNS records. The other thing you can do is you can actually reduce the host TTL time. So you can actually reduce how often the clients go and refresh their DNS records. So instead of 20 minutes, you can have maybe go do it every 5 minutes. But just be cognitive that if by cranking this down, your clients are going to go hammer your DNS servers more often. The last thing is if you're deploying virtual machines, there's network virtualization in Windows Server 2012, which will actually abstract this. So you can actually fail over virtual machines across different subnets, and that's now supported, and you don't have to worry about updating the IPs associated with the VMs. And the last thing, I'm almost done here, I promise. So we also have different security levels that you can set at inter-cluster communication. So by default, I talked about all cluster handshaking is secure. By default, it's signed. If you're going to have clusters which are spanned across different data centers, and those data centers are crossing insecure WANs, so you're crossing maybe a public internet, then you may want to set it to encrypted. You can set inter-cluster communication to encrypted. Just a disclaimer, there is a little bit of perf cost associated with that. All right. That was a marathon. That was a ton of information. A key takeaway. With going out and thinking about your clusters as you leave, just remember, you got to have resiliency. And I don't really care if you want to put in multiple NICs, if you want to put NIC teaming, or however you want to accomplish it, you just got to achieve resiliency. The other thing is quality of service, quality of service, quality of service. Multiple NICs achieves quality of service. You want to do teaming, you want to do converged networking, you want to do quas policies, you want to do VLANs, all good. Just make sure you're achieving quality of service. When you're thinking about CSV, brings in a few more things to think about. And in my general guidance is I told you a ton of nuts and bolts of how things work under the covers. All these little settings, you can tune heartbeats and network metrics and who's going where and what's doing what. So I gave you all the internals, but my real hope is you don't have to go mess with this stuff. You shouldn't walk out of this session feeling freaked out that you got to go completely reconfigure all your clusters. By default, I'm hoping everything we do works just out of the box. And if it's not, then I'm receptive to that feedback. All right, and with that, I apologize. I am over, and I want to thank you very much.